Well, yeah.
I kept erasing.
Let me show you what I think Rachel's talking about, and then I'll show you kind of a workaround for it.
She extruded something to an inch below where it needs to be. And she wants
Yeah,
to pull it out.
exactly. So I'm gonna build that wall. And so so I take these and I did a trim, and then I'm going to join them together. So I've got a clear. That's a really common technique, right? Going from 2D to 3D, and then I'm going to extrude this just to get a wall. Okay, and I believe Rachel's question is like, what if, like, I want it to go down to the floor? Like, oh, doesn't touch the floor. And you guys are correct in that I said you really can't like do that. Remember I said like there's no such thing as like stretch. Whereas in like AutoCAD, yeah, you just grab the end lines and you pull them and they snap and everybody's happy. And in other programs like Studio Max and in Maya and other programs, you can just grab points of polygons and just pull them, and it makes total intuitive sense. In Rhino, there's a way to do it, and I'm gonna show you. It's a little hacky, but it works for doing a stretch. So I've got my geometry, and this is actually a great introduction. You've given me a great starting point for the day, because I'm going to talk about the difference between surfaces and solids again. And I think I've talked about this before, but I think it's really good to review, because it's the most important thing in Rhino. So remember I said that, like, if you have something that appears solid, like nothing's really solid, it's just a bunch of surfaces that happen to be joined together. Right? And so this thing is actually, there's a front face and a back face, and there's a top, and there's these surfaces here. And since they all happen to be joined and they face us, we think it's solid. Right? Okay. But then, so I can get those surfaces if I explode this. Right? So I do explode. And now it's actually a collection of individual surfaces. Okay? Okay. So I'm going to go back one step before I exploded it. So there's these different things. I think I showed you guys this when you have like a line where you can turn on the points for the line, right? And you can move those control points around, and so you can kind of edit a line after it's been made, right? And then if you right click, you turn it off, and there's your line, right? So you have different modes with that object. You can do something kind of similar, but you can't do it with solids. So if I have a cube, let's say, it says cannot turn on points for poly surfaces, like game over. I can't stretch those, right? But if I just have a surface, I can. Okay, so with what I've shown you, what might be the technique for stretching that wall? If I can't stretch a poly surface, but I can stretch a surface.
You're going to delete the face and stretch both sides.
What's that?
You're going to explode it.
Yeah, if I explode it, it gives me surfaces. And then I can pull the surfaces. Okay, yes, very good. Yeah, okay, so let's go to front view. So I take this, explode it. It's going to say 10 surfaces. Now with all those selected, I go in, I turn on the control points, and I can grab these, and I can move them, and if I'm careful, I can snap them to that line that I've created. And see, this actually creates a little issue up here, but I can kind of I can probably pull those too. You gotta be careful about what you're doing,
Did it bring the back up the wall down too?
Yeah, I think that's what I had to. Well, and then I pulled that out of the plane, but this is why we need project.
Oh, I see. So you just selected all of it and you pulled them all. Okay.
Yeah. Actually, I guess what happened was that I didn't. Something happened here. I'll have to look at it.
Well, you can just redraw the wall.
You could. Well, yeah, but that's the thing that we're trying to avoid. But that's what I would have. That's what I would tell you. I just the question was asked, like, how do you do this? And yeah, actually, Stefan wins the $1 million prize. No, seriously, like, you really want to draw it right in the first place. Like, this isn't like Studio Max and these other programs that are really for animation. They're kind of fast and loose. Like, you're really pushing and pulling and squishing and squashing things because you're animating them. Like, they're kind of squishy anyway, right? They're not precise, they're not like surfaces. They're not mathematically precise. Rhino is like hardcore, right? We're making yachts and submarines and like, you know, like jewelry. Like it's very precise. And so it doesn't like you just willy-nilly pulling stuff because that's how you create inaccuracies. It's not designed for like that kind of like loose play. So that's why it really doesn't want us to do this. Now, I could be completely invalidated when Rhino 5 comes out, and then finally you can start to stretch things. But I believe that that's what the authors had in mind, was that you don't want to create holes in your geometry by pulling stuff around. So yes, Stefan's completely right. You would draw it correctly the first time, or you'd redraw it, because that's how you ensure precision. So anyway, yeah, that's long-winded. Coffee. And, but... just to, you know, but anyway, you can, you get the point. You can, yeah, I meant to do that. Then when you're done with stretching, once you get it stretched, you know, properly, you just join them all together, and that will actually recreate your solid. I mean, you turn the control points off by right-clicking and then join them all together. Okay, it's tricky. It's unadvised. There's no easy fix, but it is possible, and that's why I don't want to just be dogmatic. It is possible. Okay, so, yeah, any other questions about, that's a great question about that model, though, yeah. Any other questions? No? Okay. So I want to talk about a couple of things. First, I want to show how to kind of construct, well, no, I want to go back. So I talked about Booleans, but I don't think I really talked about the difference between them and other methods. And so what I'm going to do is I'm just going to make a quick demonstration model for you. And you just follow along. You don't have to actually like make this, but
This may be silly, but like, what does like Boolean actually mean?
I'm gonna talk about that. It's not silly at all. Not silly. Actually, I'm gonna do this. So let's say I've got this geometry, and this is how I created it. And the way that I created it might be the way that you created it, right? Where you snap into different things. And so, but based on what I've talked about, like, what do we not like about this?
There's like three boxes
inside each other, right? They're actually, and in one place there's three inside of each other, right? And so when we make 2D, we're going to get like 6 extra lines. Each one's going to be overlapping each other. It's not going to be clean. What we really want it to be, like in our mind, it's like this, you know, right? It's like, oh, it's clean, it's pretty, you know, but in the geometry in the computer is like crap. For all the reasons I explained, it's going to be hard to material, it's going to be hard to analyze, it's going to be hard to make 2D, like, we don't want that. Boolean operations, I think I've talked about this before, but I wanna refresh your memory. So I've got a couple of solids. Dun, dun, dun. I was thinking of Clark, and I'm thinking of spheres here. You know,
Just keep going.
make it work.
And make it 28 feet.
Sorry, I'll just make your building. You know. Okay, let me go and hide these. So Booleans, right? Okay, Boolean. You guys know about like true/false tables, like where you sort of get like logic tables. Like if things are true, if both things are true, then it's true. If one thing is false, then the statement is false. If both things are false, then it's true. Like that's what's known as Boolean logic. There's a guy named Boole, and that's what Booleans are named after. And so it's like in the geometry, it's like if two things are true, like if you add them together, then you get a something. If you subtract one from the other, you get some geometry. If you do like an intersection of the two, then you get some new geometry. So you use the sort of like like the true false of the two geometries, like the intersections of them, to create new geometry, which can actually be kind of intuitive for us because we like to think of things as additive or subtractive operations. I think you guys, we talked about this before, but I'll refresh it. So there's Boolean two objects or Boolean union, and I'm just going to do these explicitly. So there's Boolean difference, which is like subtracting one from the other, Boolean intersection, which is the intersection of the two, and Boolean union, which is join the two together. So if I do Boolean union, let's first look at these in wireframe. So they're inside each other, right? And if I go, I'm going to do a Boolean union, and I select the two surfaces, and then crunch, 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 and the two are like one thing, okay? And if I look at it in wireframe, like so you can see this is actually trimmed away. and this has been trimmed away, and you've got this thing. And so if I go in, and this will tell you what happened here. If I explode this, and I delete this outer surface, you can see that that's actually been trimmed. And if I go in and I would delete, you know, these surfaces. So what the computer does is it looks for the intersection, it uses those lines, it trims them, it erases what's inside of the other form, and then it joins them all together. So it's actually doing automatically all the stuff that we do, you know, that we could do in Rhino. Okay? The problem with this is, as I said before, is that when you get into more complicated forms, like this works pretty well. Like I wouldn't want to do all that with this. It's more complicated. But as you get into more complicated forms, the computer doesn't know what to erase and like what not to erase, and it doesn't know what your intention is. And when you get more and more complicated forms, the Boolean like algorithm, the kind of automated thing, gets slower and slower, and it like crunches. And so it's better to just model it cleanly yourself than to have the Boolean like do it for you, right? And I found, and this is almost like some kind of like, I don't know, what do they call it? When something can happen wrong, then it will happen.
Murphy's Law.
Murphy's Law. Whenever I want and I need a Boolean to work for me, it just doesn't. And so you need, and I didn't know how else to do it. So I just kept running it, and then it would crash. It would take like an hour, and then I would like miss my assignment or whatever, right? So now I know how to actually model it without the Booleans. That's why I teach this, and that's why I emphasize it. Because Murphy's Law, you know. Mm-hmm. Okay. So this is an okay way to think about this. I'm going to show you the other ones just for the sake of completeness here.
Is there a reason that so it exploded the cube, but it did not do that to the sphere?
Because the sphere is one thing; it's one surface. The box is 6 surfaces. Okay. Spheres are technically, from like a topological standpoint, they're like a handkerchief that's like sewn into itself. Like they're one surface that's like wrapped up. They're like a hobo bindle. I mean, honestly, that's what they are. If you do like an intersection, did I delete these? Let's see here. Boolean intersection. Oh, you know what? I need to do these in order. So some of these take 2 things. So then I select a second set. Yeah, and then it crunches. So that gives me, that's another operation where it does the trim. But then it keeps the stuff that's inside each of them. So it decides to delete the outside. Once you understand it, it's not quite so magical, you know. Like, I mean, otherwise, this is the way that I teach. And then lastly, let's do Boolean difference. And so you select one object, and then a second set, and it will remove it. And you can do them in different orders, and it will remove the piece. So that's the one that I find most useful, and that's the one that I find is most abused by people. And what do I mean by that? And this is what I was talking about before, when the way that people make facades is that they have like a lump of like gingerbread, and then they have these like boxes, and then the way that they make their facade is they do a Boolean difference. You know, and they do that. And you're like, okay, Nick, what's wrong with that? Like, what's the big problem with that? And well, again, it's like that's more operations, you know, than the thing that we did. And as your building gets more complicated, like if you have like 100 windows, then it really becomes like a problem. It's easier just to extrude it than it is to do that.
You mean because there's mistakes in the calculations, or
because it has to automate? It's like okay, find the intersection, delete the inside, delete the outside. Find the intersection, delete the inside. So you do that 100 times, and it increases the like computation of it. Whereas like if you have the outside selected and all the windows selected, and you extrude it, it knows what you want to do. All you want to do is make a planar surface of that and extrude it. And all it means is that you're adding the surfaces to the outside of it. Like it's actually quite a bit easier to work with. You know, Lindsay, did you have a question?
Yeah, what does the Boolean split do?
Boolean split, that's a good question. So split just gives you the pieces. So I'll show you. That's useful too. So yeah, Boolean split. If I spell Boolean. Fair point. So select one set, oops. And then the cutting, actually, yeah. And so, okay, what happened? It actually gives me the inside and the outside, and it just keeps all the parts. So the other method is sort of like a destructive method. That's the other thing I don't like about this too, is that it like removes all the pieces, you know? With an extrude, you can say like that you want to keep the curves that you used, which are useful for other things. Booleans are typically destructive. That means that the pieces are used and they're destroyed. You don't get them back. And Rhino is kind of a destructive modeler, which is one thing I don't like about it either. So split will at least, I mean, this gives me, you know, the outside boxes, and it gives me the piece that I cut. So I can maybe do something else with these, which can be useful. So yeah, Boolean split. It's actually. So
you're saying you could move those now and there'd be holes in that plane? Is that what you're saying?
Well, it actually gives me the hole.
Oh, okay.
Sorry. Yeah. Thank you, Clark. that's actually more informative. But check. So yeah, it gives me. This is the piece I used to cut. These are my cookie cutters. This is my delicious cookie, and this is my dough that's left over. So you get everything left over. All right. So yeah, I mean, split is useful. Yeah. Okay. So again, I don't want to say that you can't ever use it, but I want you to have other tools in your belt. All right. There's nothing that you can't Boolean that can't also be done by just taking a geometry, splitting it with another piece of geometry, erasing the surfaces, and then joining everything back together again. That sounds like complicated, but okay, that's actually what I'm going to do. So.
Like even for example, let's say like with a sphere.
Yeah, it doesn't. The complexity of the geometry doesn't matter. It's just that it's the amount of automation that you're asking the computer to perform.
I'm just trying to get you to do it with a sphere again.
I'll do it with a sphere. I will show you an awesome sphere thing. Sphere thing. That's a technical term. So go back to these now. Right? And what do we want this thing to be? We want like this to be a surface. We want this to be a surface. We want that to be a surface. That's a surface, that's a surface, that's a surface, and then we keep these caps, right? We want it to be like fewer surfaces so it's a clean joint, okay? And you'd say, oh, Nick, I just learned about this Boolean thing. What if we do that, right? All right. So Boolean Union. Crunch, crunch, crunch. Look at that, though. Does it pretty much look the same as the other one? I mean, I click it and it's one thing, but it's still got those joints in it. And if I make 2D, it's going to show those joints. If I go in and if I look at it as, if I explode it, surface, 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 surface. No good, right? I've taught you well. I mean, you could say, again, you know, Nick, that's perfectly the same. I don't know what you're talking about, but the geometry isn't the same, right?
Could you select the surfaces and join them? Or?
That doesn't work that way. Good thinking. Yeah, right? Could you kind of like heal them? Could they Boolean themselves together? Wouldn't that make our lives easier? No, unfortunately. But that's good thinking. Again, maybe Rhino 5 will solve all of our problems, but I just think it's not the logic of it. Like, if you're gonna do it, you do it clean. So there's a couple of different, what are different things we can do with this? You can what?
Well, no, right.
I would pull the top one out of the bottom two.
Okay, so that would be that. Well, let's just say we modeled it this way. Okay. I mean, you could, yes, you could, but that still gives you these two running into each other, right? What was that one? I'm sorry. Yeah, I think that's a way to do it. Or there's another way too. It's a little bit more work, but it's maybe even easier. What did we do when redraw it, right? I'll show you both methods, and I'll give you guys a sense of how this kind of works here. Okay, so let's go ahead and explode these because we got to get the surfaces out, right? And we're going to keep some of these. Like some of them are okay. But yeah, what you could do, and there's different ways. Like you could take the Polyline tool. I'm going to go ahead and actually make a new layer so I can separate these out. Actually, I'm going to go ahead and lock this. How about that? So I can't touch it. And I could just go in with my Polyline and draw, snapping to it. Since I snapped to something else there. Gotta be careful. What am I? Oh, intersection. I don't want that. If you're very careful, you could draw the edge of that. And then once you've got, since this is actually a flat piece, like I've just traced it, I can do what's called a planar surface. So planar surf. And that would give me that clean surface back, right? That works. Like you could do that. You could trace the edges of it and you could make exactly what you want, right? And but that's kind of time consuming. Like I clicked that thing like 5 times and I had to make the surface. There's another way that's slightly less work. I'll show you. I could take these two surfaces and I could do duplicate border. And what dupe border does is it gives me the outer edge of that surface. Okay. And then I could go through and I'm going to go ahead and say select invert. And I'm going to hide these other ones so that I just get these. Then I can go in and I can trim these, or if I spell trim correctly.
What was the
Join, and then that's one. So that's quicker. There's a command that lets you do like duplicate border. That's the command, dupe border. And I'm recording this too. Okay, so you can do that. That's slightly less work, and especially if it's really complicated. Like all you want are the intersections of the two things, and then you get a clean edge, and then you go in and do planar surface, and you get your clean piece. That works, right? Okay, the other method that we talked about is if I go through these things, and yeah, I can use these to start to kind of trim each other. What you can do, I think about this, how you want to do this. This actually becomes, so actually you need to do a combination of these things actually, because these you want to trim, because you want like this piece here, you know, that like you could trim. So I could take these two pieces, and I can get the intersection of them intersect, and I get like that line. I don't know if you can see that on the screen, and then I can say trim. So trim, and the cutting object is like this line. And then I'm going to go into wireframe because I want to see the geometry in there. And I can say what object do I want to trim. I want to trim that line. And I want to trim that. So you can see that this one, I cut this piece. This one, I cut this piece. Oops, don't cut that one. And that's going to give me, you know, these pieces. I actually, with the faces of these guys, I think I want to do that method where I found the border and I trimmed it so I get that clean piece of it. But with the intersection thing, I'm going to do that. I could do that back here. Same thing. So intersect, and then trim, and then I'm going to. I can probably use like ghosted or something. Yeah. There. See, then I can see what I'm doing. That's probably easier. Yep, so I got rid of those. Then I can go in, and the last thing I'm going to then, so these I get to keep. These are now, they're their own pieces here. Oops, the top ones here. Like that. So then for the bottom and for these outside pieces, I want to go ahead and you can do a lot of these at once. So I can hold down shift and I can click these. And I can get the edges of them. Do border. And then again, I can go in to make things easier for myself, say select invert, hide. And then I'm going to go ahead and trim these out.
So select invert because you had the border selected. You hit select invert
and hide, and that hides everything. Yeah, you always, you know, turning off layers, locking things, locking the layer, right, just cleans things up for you. You don't accidentally pick stuff. You're focusing on the stuff that you want to model and not something else, right? And that little select invert trick, we do that in Photoshop, right? Like that's a really handy thing in almost any program is take the thing you're working on, select everything else, and hide it, right? I use that in so many other programs.
I know that you're showing us this way so that we know how to do it.
Mm-hmm.
But if you were going to just draw this, would you like draw the L extruded up and then put like a box on top of it and then join them all together?
You mean like how would you just model in the first place?
Yeah, correctly.
Well, this isn't incorrect. Like, because again, you have to think of, guys, when you're modeling in Rhino and when you're doing like surface modeling, it's actually it's like you're making a suit for yourself, like, or making yourself like a pair of shoes, right? You take your foot, right? That's the solid. And you take a tape measure and you wrap it around it, or a piece of string or whatever, and you measure it. So you get curves like based on your foot, and then you take those curves and you make like a foot skin. You make your shoe, right? So solid modeling is like that. Like, you use geometry as a reference to make cleaner, like better geometry, right? You're not making your foot, you're making like a copy of your foot. Does that make sense? Same thing like if you're going to tailor a suit or something like that. And so you use like solids to make lines to make solids. Or you use lines to make solids to make lines to make solids, right? So you keep going back and forth.
So I guess then the question would be, is there not like more successful or like a easier way?
Yeah, there's a clean way to do it, guys. If you were going to do this like and not go through the rigmarole, would be to take your drawings and instead of like modeling by extruding like lines, drawing surfaces for each of those views, and then making sure that those join with other surfaces, and then making sure that those are watertight, and then joining them together. So you just drawing the surfaces cleanly is how you create a good, clean model from the get-go. My thing is that starting out, like, you don't think that way. Like, I never thought that way. Now that's how I model, but I'm trying to teach you guys like the kind of theory of how this thing works, right? Yeah, if you're like an expert, you just model in surfaces, you know, and then everything's just clean from the get-go, okay? If you want to try that with your drawings, you know, like what you could do is that, okay, for our house, let's say, right? You trace the edges of the of our facade, but instead of extruding it, just make it a planar surface, okay? Then you would, you know, like basically trace that edge on the inside of the house, right? And then that's a surface. And then you would surface the skin of the windows between the two, and then you'd surface the top of it.
So then it's like you have your exterior, your interior finished wall, and then
Yep.
Gotcha.
But see, like, I find that less intuitive yet. I'd rather just make the thing that I want and like trim it. You know, start with my foot instead of starting with the lines to make the shoe. You know what I mean? Like that. Yeah. Wait, Stefan, you think about that. That's all. I never used that analogy before, but I'm going to go with it.
There's a lot of different ways to do it.
Exactly, and that's the point that I want to make with you guys is that you do whatever like you're comfortable with, like whatever you understand, and whatever produces like the best result. Like I'm going to show you all the different ways, and I'm going to teach you how to choose between them. But it's up to you to choose like what you want to do, right? If you want to use Booleans, like, go at it, because again, there's nothing wrong with it, but it's going to make your job harder like later, you know. So I just want to show you, once again, not to besmirch my teachers, but no one ever taught me this, you know, like really, like I'm completely had to be self-taught. Whoa, deleted everything there. Okay, so let me go in and maybe if I join these. They're all one closed. I don't want to do that. So you go through and join, and then planar surf.
What happened when you joined them all at once that you didn't like?
Oh, it actually made them all one six lined like closed curve. I didn't want that. Clean. Beautiful. Send it off for fabrication. Okay. So then we go through, and I would go through and like erase these other surfaces that I don't need. Or, you know, I could do the opposite. I could pick the ones I want. Actually, that's smarter yet. Turn the layer off. Yeah, but I need to get these guys over there. So I'll choose the ones that I want to keep and delete the rest. So here I'm just holding shift down. I missed that. So these are the ones I trimmed before. Oh, those need to be trimmed. Anyway, so I don't want to keep doing this, but you get all the pieces clean, like all the ones you want, join them together, and then you know how to check for solidity? Remember that? So go F3 to turn on your properties menu, and you pick your thing, and you go details. And it should say closed. These are the like three of the most glorious words in the English language: closed, solid, poly surface. If you see that, or closed solid, you're good to go. Okay, the 3D printer will love you, and it'll spit it out. Yeah, that's what you want. That's why I really hammer this home, because that's hard to achieve. Also, if you, this is actually a good point to make as well. Okay, so if you have a solid, you can do solid operations on it. And what I mean by that are Booleans, okay? If you Boolean something that's not closed, you won't get that solid cap because it's just a bunch of surfaces, okay? So if you want to do a Boolean on like this guy, you really want that thing to be a solid and not three things, because otherwise you get three, you get three things that have been Booleaned instead of one thing that's been Booleaned, okay? So actually, if you want to use Booleans, like you have to play with solids, okay? You can Boolean a surface, but I think when you do it, you're thinking of solid operations. Does that make sense? So it's like, you really want this to be clean, because then it's going to produce a clean Boolean later if I want to say Boolean a sphere out of it or something. Okay. It'll make sense when you try to do it, but that's the thing is like if you have like if that's surfaces, let's say, and that's a solid. It's gonna produce some really strange artifacts. Like the base of this thing is actually gonna be overlapping. Like it's not gonna be that clean for you. Okay. Okay. So in your models, I wanna try to encourage you guys to try to model cleanly. Like the goal is really to get it out, but I really want you guys to try to make it as nice as possible, because again, it's just gonna look better. I mean, for every other phase of your design, it's gonna look better. It's gonna function better. It's gonna be true to what it is, right? Like there really isn't stuff sandwiched in here in the real world. Okay. Okay. And another thing too is when you take sections of it, you know how we took sections of our site model? And if you have stuff sitting inside the ground, right, it's not going to give you the section that's really true. So if you do this thing, you're going to do the amount of time that it takes you to do it cleanly is probably less than the amount of time it takes you to clean up after yourself when you're doing sections or when you're adding materials or like whatever. It's like, it's a good habit to get into. It's like if you don't brush your teeth every day, you have to spend more time in the dentist chair. Okay? So just brush your teeth. Or go to the dentist, maybe you like that.
Coffee brings out analogies in you, is that right?
Maybe I don't know. I'm on today. I'm on the analogy trolley. Okay. Okay, goodness. Let's talk about something else here. Okay. A lot of your buildings have windows. I would say buildings have windows. So I want to talk about a couple of things that you guys can do to model windows, okay? Now I know like in Revit and other things like that, they have these like parametric windows and first of all, we don't have that. Second of all, how do you model a window frame in the first place so that you can like feed it to Revit? Like I think that's actually a useful thing to know, okay? So this is going to be, let's say this is our facade and that's a window. Okay, so in your buildings right now that we've done are kind of tofu. You just punch out a window, right? You don't have a frame in there. So let's talk about how to put a frame into something. So I'm going to start where we left off, and I'm going to extrude. Oop, I need to cap this. Oh wait, I'm in the wrong, I need to go shaded here. There we go. That's right. And disable stabs. Disabling stabs can be really good too, right? If you accidentally start snapping to stuff. I think I talked about that, but so I've got my window frame. Actually, what I want to do, this is a key here. Well, no, I'll show it this way. So I got my window frame. What I can do with this to make things easier, I mean, I could go in and I could just trace another rectangle, you know, if I turn snaps on, and I could just draw. What I want is a curve, basically. You could draw a rectangle. You could explode it and then duplicate the border. And I need to do that because if I just duplicated border on the geometry, I'd get every single edge of that thing, and I don't want that. I'll actually show what I mean here. If I do duplicate border, actually, well, it won't because yeah, I need just a single thing. So then if I do dupe border, I get these edges. I don't know if you guys can see that very well. Apologize. See, it's like this edge and that edge, but I need a surface to do that. I can't do it as a poly surface. Or I just draw it because it's flat and, you know, whatever. Okay, so I've got this piece here, and okay, you'll typically have drawings of this stuff, like so you could kind of reference this in your drawing, and in fact you probably will. But I'll show you this as a model. So I mean, in order to get the frame, you can do a couple things. I'm going to offset this curve, and there's different things. You can set the distance as a number, or you can set the distance as some distance that you move the mouse and you just sort of click. So that if I do that manually, is going to give me that distance. I'll do it here actually. So click and and then that gives me that offset. Otherwise I type it in. So I could say like I want a 1/2 inch offset. Okay, and then you have to click the side you want, and that gives me the offset. So I get these two sides. Okay, so that is the beginning of my frame. It's the frame that's off my window. To make the actual frame, I'm going to pick both of these lines. Can you see that? There's this yellow and that yellow. Okay, and in 3D, that's what I'm talking about. Okay. That's okay. So remember when we did extrude, and if you have something inside of an extrusion, it cuts a hole? Planar surface works the same way, actually. I can get a surface with a hole in it. Now it's 2D. It's got no thickness to it at all, but I made a surface, okay? Extrude actually just makes a planar surface and then another planar surface at a certain distance, and then it makes all the surfaces in between that. So again, extrude is kind of like an automation as well. In the same way that Boolean automates like this split and this trim and this, you know, join, extrude is actually automated too. It's a planar surface, okay? But we're going to do this a little bit differently. I mean, you can actually do that. That's actually a good point. So I can take these two pieces, oops, and I can extrude them as well, right? I can do that, and that can create my frame. So you can, you know, that is, okay, now what's like so bad about that? What's that?
It's got the extra line.
No, that's what, I mean, that's a window frame. But what do you guys, I mean, maybe I'm being too vague here, but it's flush with the edge though, right? And that's really not the way that windows work really, right? What's that?
You want to bring it in?
Yeah, I mean, well, you could bring it in. That's a fair point, Clark. You could bring it out a little bit. It depends on the detail. Some windows are flush. I mean, that may be a way that you detail it, you know, in your building, but you need to be aware of it. Okay. Geometry does most of the work in the realism of your models and in the and in like architecture, right? Because when you have things that are offset or inset or extruded, they create shadow, right? They cast shadow, they capture light, and so like you really want to look at that detail in your building and decide like how it's actually working. And so when you extrude it, you can do a couple different things actually. Okay, so that I did, and I just actually matched it to the inside of the house or whatever, right? The wall. I can take that and I can explode it, and then I get a surface here. You can extrude a surface, and so that I can actually extrude out, and I could do the same thing on the back, and maybe it's actually further in, and so I get I get like kind of a frame that has like a different inside and outside. Okay. What's so awful about that?
Now you've got,
Yeah, it's like three surfaces. Okay. What's not so awful about that?
you accomplished.
Yeah, I did it. Like it looks like it's supposed to, right? So again, what do I mean? Really, at the end of the day, you get the job done. You know, like maybe you just go to the dentist later, but at least you get the you get the window out. It's more intuitive to me because I know that there's an inside, you know, like where it comes, you know, I know the distance of how far it's extruded on the inside of my wall. I know the distance of how far it is from the outside of the wall. I don't have to do any math or anything like that. Like it just makes sense to me, right? So doing it as like three surfaces is not bad. You could always go in and really, what's the only part that's really like messed up about this really is the inside, right? Is that there's three things in here. I mean, this is actually outside of this. This is actually outside of that, you know? Like it doesn't really run through here. It only runs through on the bottom. So you could just redraw the inside of that window. Those four, you know what I'm saying? Like I could draw this surface here and draw that surface, and I would have pretty much all the other surfaces are that I need, right? That'd be pretty clean. It wouldn't be too bad. That's my foot. Like I could trace my foot and get my great custom shoe. Okay. Yeah, I'm gonna keep milking that one. The other piece of this window. Okay, so that's kind of a very simple. That's a very simple like frame, right? And that may be all your window actually is. But there's other things that you know might do, right? I'd go in and I could draw another rectangle, and then I could offset this. And maybe I offset this one a 1/4 inch.
Do you have to take into account materiality when you're building this? Because if those three poly surfaces were three different materials,
then making three different things.
But do you have to know that from the beginning in terms of what we're?
Well, for your model, I mean, this is a building that someone already designed, so you would have that information. If it was your own project, you may just have to change it later.
Is that what people do? I mean,
when they're doing designs.
Yeah.
You know, typically people don't design in model in this kind of way. I mean, so you usually have an idea of it. It's not really. Younger people tend to design in Rhino. I don't know if it makes for a better building. Like to me, it's like if you want to, you have a design, you're representing it in 3D, and then you're like taking it further. Yeah, that's a fair question though. I mean, the thing is that I've shown you though how to go back. Basically, you could always explode it and make it three things, or make three things one thing.
Yeah.
And that's the flexibility of this method. That's a really great question though. I mean, yeah, I think you want to model things based on what the materiality is. Okay, so I've got these things. I've got this offset. What I'm actually going to do with this though is I'm going to move it slightly inside my window, and then I'm going to extrude it. And you probably need to snap to something else, but anyway, yeah, you could find a line to snap to it, and so you could create, you know, like a more complicated mitered kind of frame, you know. So again, you're working in 2D, you're working in 3D, and then you're working spatially to create that condition, and then from inside of there, I could go ahead and looking at the midpoint. I just drew a rectangle. You guys got that. And then if I make this a planar surface, that's my glass. So just by like thinking about it, you know, as a collection of offsets, like you don't, it's okay because I'm borrowing bits of this geometry, so it's still clean, you know. Like this isn't running inside of that. Like as far as like applying the material goes, as far as getting the lines out, like it's going to be relative. If you wanted to go in and like mess with that, that's okay. But I think for things like these, it's okay to have some of these, as long as they're sitting on the surface and not in the surface. Like that's okay. And it's very easy to make. When you make glass guys, I would just model it as a single plane. Just take a rectangle or even draw a plane at the midpoint of your window frame, and that's your window, right? And as I said frequently, in computers, you get copies for free. So if you have windows that are like repetitive, in most cases you do, just make one of these things and then just copy it to the rest of your, don't like make each one. I mean, it sounds stupid, but I see students do this all the time. Go for a walk, you know? Like, go play with your dog, take a bath. Don't spend your time like modeling individual windows and things. And this is why Revit's nice, is because you have types of things and it copies them, right? But this technique can be applied to pretty much any kind of window that you want to generate. And then if you wanted to add like, you know, mullions, you could draw, actually let's do that, mullions are great. So I'm just gonna draw, this is where project is gonna be helpful. Because if I didn't have project, right, it would snap where I don't want it to. This is a really lame one, but I'm gonna do it anyway. So offset, because it proves the point. Both sides. Oh, I didn't click it there, but anyway, we can fix that. Then you can like trim them, you know, join them together, extrude them. You get a mullion for that. Float that inside your frame, right? That's so pretty straightforward.
With,
Lindsay?
I have that Eureka algorithm.
Yeah.
And you know how those windows lift up? How would you go about modeling that? Because it's not actually in the plane of the building. I guess it could be, but
Model them
most
closed.
of the time they're open.
Yeah, you mean the ones that actually operate?
Yeah.
Yeah, model them flat, group them as one thing, and then you can always like hinge. You can always do a rotate 3D with them and hinge them. Is that okay? Yeah, we can talk about it more specifically, guys. Like, please, if you have like your specific models, like once we get into it, I want to answer your questions. I'm just trying to give you a general like sense of this stuff, but yeah, everybody's gonna have little things that are a little different.
So you're looking for that level of the detail?
Yeah, because I mean, if it was just punched out, like I think these aren't that complicated that you can't do a little bit of detail on these.
Right.
Like this is the rich stuff that's really gonna make it like look nice, and in your projects too. Like you don't just make a building in Studio and punch a hole in it and put a rectangle in it and like call it your window. You know what I mean? Like there's ways to detail stuff like that, but I'm actually trying to encourage you to even design differently because I'm showing you like what it's going to give you in a model. And when we get into rendering, I'll show you the difference. It's tremendous, like how much better it looks with a real like frame in it. You know?
With that mullion, would like in this case, say it's a window like that, would you give that a thickness versus like a
The
curtain
mullion?
wall mullion where?
Oh, would you give it a thickness? Yeah, you still give it a minor thickness. Like, I mean, I don't give glass thickness because I don't need the physical properties of glass. Like, I don't really care about that. All I care is that there's the transparent material. But with a mullion, it's going to cast a shadow, and if you cut a section of it, you know, it pays to make it like real. You know. One last thing, well, not a last thing, but I want to show you something in this. I'll show you something else. Okay, so I went back to my curve, you know, just as like a rectangle. Okay, and I'm gonna do an offset, and I'm actually gonna keep it at a 1/4 inch offset, and I'm gonna go in and with my midpoint. Hang on a second, sorry guys. Oh, if you have project snaps on, it keeps you from doing that. Okay.
What
So
does S-track mean?
S-track means that like you can smart track. So it's kind of like an AutoCAD when you're, if you don't have, I'm trying to explain this verbally. It's basically like you can do a snap to something at a distance rather than the actual snap. So it's like you can take a point here and a point there, and you can find the intersection of those two. So yeah, the S-track is like that, only it's in Rhino. Yeah, it's like tracking snaps in AutoCAD. Okay, so I did this offset here, and I'm going to extrude this, and I'm going to snap to the back wall. Okay, and then I'm going to go in, and I'm going to go ahead and grab This is always hard to do. This is why you don't really model in 3D, because it's easy to get lost. I'm an expert. Okay, offset, and again, and extrude curve. Oh, you can get like reveals. So you have like a gap between things, like pay attention to those. Those are also another source of like shadow, right? So you have the gaps between panels of things. If you have, you know, if you actually have like a reveal in behind you on the sides of your mullion. Some of you guys have these, okay? So just you can extrude in the negative, or you can start that extrusion, you know, halfway, you know, like whatever that is, if it's only an inch reveal, but you can get those reveals in your geometry. I'll show you something else. That's another way to do it that may be of interest. And see, I exploded that, so all those are there. I think I showed you guys this. Okay, yeah. I'm gonna do something, and I'm gonna ask you where this came from. So I've got my. No, I'm gonna do it this way actually. So I was in front view, so now when I make a box, it actually makes it, you know, in this. So that's what I mean by, I think I've said this before, but the last orthogonal view you're in is where the boxes are going to extrude from. So I was in front view, I went to perspective, so now I can extrude this in the facade view. Okay, so go to front view. And I drew a rectangle. And I'm going to move this out. And go to front view. Project. Remember this? And I'm going to project it onto my surface. Okay. And I'm going to go ahead and delete these guys. And then I'm going to say offset. And I want to do this maybe an inch, just for exaggeration. Whoa, that's huge. My scale's totally off here. Offset, let's say 0.33. Okay, so I've got these. I'm gonna take my surface, my solid, and I'm gonna make it a surface by exploding it. Not export. Explode. And I've got this surface here. Okay, I'm gonna split it using these. So now I've got this and that and that. Oops, that. Extrude surface. And I'm gonna delete input and cap it. Oh, except, yeah, okay. And then I can go through, and I've got the surface that's inside there. Explode it. Reveal. Exactly. Thank you, Lindsay. That's exactly what I want to say. Yes, that's what I meant. But now it's like a precast concrete panel with a reveal in it on the side of your building, right? You can go all, you know, like Tadeo Ando on your building, right? So like when you do you could do the concrete tensioning holes, or the things that you just trace that onto the surface, project it, split it, extrude it, join it back to, you know, easy, join it back together again. This is way better than a texture. Like a lot of people will say, and I'm one of these people though, I guess, that textures can really give you a lot of detail in your buildings. But there are some things that you want to texture, like a wood grain, and there are some things that you want to make geometric, like reveals. I wouldn't want to take a picture of a building with lines in it and apply it to it when it's really about the shadow that it casts, right? What?
Well, how would you do that? Ever take a picture and put
People do it in video games all the time. It's way faster though. I mean, textures, because it's like, this is one surface with a texture, processes and renders like faster than like 16 surfaces, and it's also faster to do. And at a distance, it's okay because you wouldn't notice it. But as you get closer, these kinds of things too. I would not model like brick mortar. That's kind of a reveal, but I wouldn't do this for that. That's a texture. Make sense? But I see people that do this to like that kind of thing.
So it's a scale issue.
It's a scale issue. Like think about like a like beautiful concrete. Like I wouldn't want to just map that. I'd want to model it. But like brick, I've never seen brick that I really wanted to model. All right. Also, so anyway, it's just, I don't know if you guys have ever considered it, like the sort of like philosophy of it, but I think it makes a lot of sense to like learn how to model this stuff in your building. It'll make your, to me, 3D modeling is what taught me architecture. Like I didn't appreciate like materiality, I didn't appreciate like geometry, like the reveals of how complex like assemblies were. I didn't appreciate like light and taking pictures of buildings like with my camera until I started to like model buildings and render them in the computer. And then all of a sudden I had to actually know what all this stuff was. Like, what's that thing made out of? I need to make a texture for that. Why is my rendering like not coming out? Well, I set the f-stop incorrectly in my renderer. And it's like, because this is all based on physical like reality, it actually impacts. It actually can actually teach you some things. And we'll talk about this in computational methods, but it's like I didn't understand math that well until I actually had to start programming stuff. And then trigonometry actually was useful, and like algebra and calculus like mattered.
Doing that next year?
Yeah. Get ready. You're not rid of me yet. So I mean, you may not love this as much as I do, but I think that it's useful beyond just like what you see, I think it'll help you think about your designs a little bit. That's why modeling these buildings, that's why I want you to model these precedents.
Well, in the first time you like do it and it's sexy,
Yeah.
You'll be like,
You get addicted to it too. That was actually my thing. I started out in school wanting to be like a painter, and I ended up being this big computer guy because I got so seduced by this kind of thing, My parents are probably happier for it.
For the final in here, is it just going to be the modeling there, or do we need to like?
You're gonna make a model, and then you're gonna make some more diagrams of it, like like you did last time, some nice 2D drawings, and then we're gonna make a couple of nice renderings of it. I'm gonna teach you how to do that. But the model is just gonna be what you make those things out of. So yeah, I'll teach you. We're gonna learn Maxwell, and then we're gonna revisit our diagramming. So instead of a building that I gave you, it's gonna be you're gonna diagram this precedent. So that you already know how to do. But the Maxwell's going to be, and we're going to do just limited like Maxwell stuff. We'll cover more next year.
What is Maxwell?
Maxwell's a renderer. Yeah, more software. Just wait. Okay, so reveals. Yeah, do you guys have questions about? I mean, this is most of what I wanted to cover today. Just this kind of theory of these kind of techniques. Is there anything you can think of? Like I've looked at your buildings. I mean, I would like to see you guys bring more specific questions into class on Tuesday. Once you've kind of looked at your building a little bit, you're like, like the question you asked, Lindsay. Like, how do I do that? Like, we can talk more about that. I'm gonna do a little bit of site work with you guys on Tuesday. We'll go back to if I have a topo, how do I cut it out so I can put my building onto it? We talked about that, but we didn't have buildings really. Now we have these projects. So I want to talk about a little bit of site work issue with this. Somebody started to say something. I'm sorry. What was that?
I think it was David.
Oh. What?
You said we were talking about the window, but I think the way you said it was like the easiest way to do it. I just didn't think of it like that. I was thinking of extruding a slanted plane out.
Oh. Yeah, just make the thing. I wouldn't even want to like think about how to make it the other way. Oh my gosh. Yeah, I think it takes a while to get into the mindset of, it's like you're just making parts. Like the way that I teach this in second year is we actually just make a bunch of like Lego pieces and we assemble the building. Then we teach the scaffolding method. But we don't always make buildings out of Legos. I mean like I-beams and other kinds of members, and they just assemble them together like little arrangements. Okay. You guys feel?
do you have an idea when you want the model? Is that
I'm gonna post up a calendar. I need to do some. I need to look at the schedule for the next couple weeks. I mean, I think about a week and a half.
Okay.
When's your final review?
27.
Yeah. So I mean, by the 20th, 2 weeks. Well, what's that?
Yeah.
Scary?
Yeah.
Why?
I'm sure it won't be that bad. It's just scary.
Have you seen your buildings? They're not that complicated. You don't have to make them like super great. I mean, if again, I would like to see you get them out. If you wanna spend some time with them later, like really like rejiggering them to really get the craft up. I just want to teach you this so that you have it. You can go back to this video. You can do it. But in the meantime, I think just getting your building out is really what I'm interested in.
So if we're getting the building out by the 20th, and then we're spending the next week rendering it?
Well, I'll show you some stuff. I think again, I mean, we'll have to see what we can do. We might just do rendering and not do the diagramming, because there's not a lot of time, and I know you guys have studio to do. But I mean, ideally, it's like I'd like to see you guys like what you can get out of something that's like this. I don't know. I haven't decided yet. So the main thing though is just this weekend. I would just look at your drawings. I know it's a holiday, so just come up with a plan for how you're going to attack them. Find the information. Spend a half an hour on Google getting pictures and things. Right. Go to the library for a few minutes. Come back next week with your partner and just crank these things out.
With a block
Mhm.
AutoCAD into the Rhino, how do you make the block turn off?
I think you can just explode it or ungroup it. I can't remember what it wants to be. Did you just put a block in?
No, I put the plans in of the house that you gave us, and the windows and doors are all a block.
Okay. I think you can just. I think there may even be a way, yeah, of just exploding it or like embedding it.
But you
That's
just
what
put the
you would
plans
do in
in.
CAD is you would explode it.
Yeah.
Then we're redrawing the things?
No, you're not redrawing them. I'm giving you, in most cases, I'm giving you plans, but you have to add to them.
So we bring those into Rhino.
Yeah, but I would not just put them in as is. I would, in AutoCAD, it's easier to fix them in AutoCAD than it is in Rhino. So like, split them up into layers, explode the, use AutoCAD for what you know how to do in AutoCAD. Simplify it as much as possible. Like the stuff that I had for our house, like, yeah, it was like a regular drawing that I made, but then I kind of fixed it for Rhino, right?
A good idea to do each wall in a different layer, touch color. The way you have your house.
I mean, think about what you're going to do with it in Rhino, and whatever makes sense to you, or to your group, right? I would definitely get your drawings, separated and aligned so that you can do the scaffolding easier. Like if you want to rotate things in AutoCAD, so you just barn them up when you're in Rhino, by all means, like use the right tool for the job, If it helps to have your stuff organized by materials in AutoCAD, like do that. If it helps to do it by drawing, you do that. Whatever. You guys know the technique now, roughly, so you'll know what'll make it easier for you.
It's probably a different question. You can group things, like different lines from different layers, you can make groups.
Yeah. Yeah, groups are just kind of temporary, arbitrary assignments. The way I did it was essentially to group things on the layers. But yeah, groups can work across layers. You just got to be careful with that. Yeah, Rhino kind of violates some rules, but I think it makes sense when you're using it. Let me think here. So yeah, for Tuesday, I think just when you come to class, I would have a sense of your building, and if anything is like a burning question, like I looked at this thing and like I have no idea like how I make this. Let me know. If your drawings aren't like quite working out, let me know. We can look at some stuff in class. But I think you guys like at this point should be able to take pictures of stuff online and photos and scan them or scale them in AutoCAD. Take the lines I gave you, make them work with it. You just mass this thing out. Again, I would like to see, because I think you have the details, like just minor things, like if it has. You don't have to get all the detail into the frame, but if it has a frame, it has a frame, I don't care if it has like 3 miters or 2 miters or like whatever. I just care that like if it sticks out, it sticks out. If it's inside, it's inside. Okay? Don't go crazy. Okay. That's what I've got. I'm going to go and upload this this evening. But again, just let me know if you guys have questions about this stuff. And I'll come up with a schedule for this. I haven't talked to Betsy yet about what you guys are working on, because I know you guys had a marathon like crit session the other night, and I'm still trying to coordinate with her to make sure that this is enough for you guys, or it's not too much for you guys. So.